All right, sorry I'm out. If you can tell by my voice, I have been under the weather. It is Tuesday morning that I'm recording this, and I am feeling a little better, so I expect to be back tomorrow. Beside the point, though. These notes can be found on Blackboard. And then my actual physical written notes can be found in the notebook on Canvas. Okay. All that stuff out of the way. Let's get started on the notes. Today is inverse functions. And you're going to learn how to verify, find, use horizontal line test, and graph. Your homework will be due on Thursday. So definition. One of the ways to find inverse, prove that things are inverses are to find f of g of x and g of f of x, and if they both equal x, then they are inverses. Sorry, I'm trying to get this away and it's not working very well. There we go. All right. So let's look at that as an example instead of that big definition. So we have these two functions and we want to show that they are inverses of each other. First, I'm going to do f of g of x. And my pen's not wanting to work. This video is turning out great, y'all. There we go. F of g of x. So g of x is x plus 7 over 4. For f of x, that means where there is an x, so 4x minus 7. I'm going to plug in x plus 7 over 4. As I simplify, these 4's cancel. And then these 7's cancel, and I'm just left with x. I also need to check the other way around, g of f of x. So same idea, but the other way around. So this time I am plugging f into g. Sorry if you hear my dogs running around. All right, so minus 7 plus 7 cancels. I'm left with 4x over 4. They cancel, and I'm left with just x. So yes, these two functions are inverses of one another, and it's because they each composition equals x. All right, so if you want to find the inverse, there's a lot more steps here than what I usually put. Mine is switch x and y and solve for y, and that's it. That's usually what I put, but there's the official steps from Blackboard. Okay. You can pause and write that down if you want, or you can go into the straight example. Okay, so if we're wanting to find the inverse, remember f of x is the same thing as y equals. So y equals 2x plus 7. I'm going to interchange x and y. So that means where there was a y, I'm putting x. And where there was an x, I put y. And then I get y by itself. And divide by 2. Which I could leave just like that. And then I could go back to inverse notation. So instead of leaving it as y, I'm going to say f to the negative 1 of x. That means inverse. Equals x minus 7 over 2. All right. Horizontal line test is exactly that. Remember, a horizontal line goes from left to right. And if an inverse of that function is a function as well, then it will pass the horizontal line test. So example, which of the following graphs represent functions that have inverse functions? So not just inverses, but like the inverse is a function as well. This one fails because it crosses 2 times. This one passes because it only crosses once. So B is the one that has a function that has an inverse. Okay. And then this part's pretty easy, the graphs. The graph of the inverse, remember that word means inverse, is a reflection of the graph about y equals x. So all that means is we switch x and y values. So here's our example. Right here, this is the point -3, -2. This is -2, 2. And this is 4, 1. The inverse is just going to be the flip of those. So 1, 4, switching x and y. 2, -2. And then -2, -3. And then connect those. Okay, so that would be the inverse. And if I'm looking at, this is y equals x. Y equals x is just that 45-degree line that goes through there. If I fold that in half and think about it as wet paint, they would touch each other. The inverses would reflect, which that's how I know that they are a reflection on the graph. All right, and that is all of your notes. I'm sorry I'm not there.